Hello, good evening. In the last class, we discussed about LOC based metric where we count total number of LOC and the entire estimation is based upon the LOC. For example, dollar per LOC or average number of errors per KLOC or number of pages per KLOC, average number of defects per KLOC and so on. Now, another approach, another method for estimating the software was proposed by Alan Albrecht at IBM in 1979, which is called function point oriented metric, FP based metric. In this metric, we measure the software on the basis of number of functionalities delivered by the software. So the focus is on functionalities delivered by the software. So is this function point based metric is an ISO approved and internationally recognized for size of the software, which reflects the measure of amount of the functionalities of the software relevant to its user. So the function point is actually a relative measure of the size of a software application, which is based on the functionality delivered by the application program to its user base. It is not technology based, that is, it is independent of technology. Function point analysis instructs to quantify the software requirements into 5 different categories of information domain. That is inputs, outputs, inquiries, the total number of internal files, and the total number of external files. So for the calculation of this function point analysis, we use direct measures as well as indirect measures. With the help of direct measures, we compute indirect measures such as quality, performance, productivity, and so on. So function point is derived using an empirical relationship based on direct measures, means countable measures of software's information domain and assessment of software complexity. So we can measure productivity with the help of function point as work product by work effort, or we can say output by input or output by cost. Now the computation of function point count is done in 2 phases. In first phase, we compute unadjusted function point count, that is UFPC. Then we compute total complexity factor, that is TCF, or it is called value adjustment factor, VAF. So for the computation of UFPC, we categorize 5 information domain characteristics. And what are these? These are number of user inputs given by the user, then number of user outputs, number of user inquiries, number of internal logical files, and number of external interface files. For number of inputs, it should be either an elementary process or control information, should be a data or control information received from outside the application boundary. If it is a data input, it should maintain 1 or more internal logical files after processing, and the input should be unique. Say for example, if 2 students inquires for books at 2 different times, This doesn't mean that there are two inputs. These two are one input only because the inputs are same. Regarding output, a valid output entity must meet these criteria. It should be an elementary process of application. It should be a data or control information sent to outside of the application's boundary. Should leave the business of the application in a consistent state and should be a unique output. Regarding internal data file, it should be a logical grouping of data or control information meeting a specific requirement of the user. It should be completely maintained within the boundary of the software, and the file should be modified and maintained by an elementary process of the application. The external file or external interface file, it should be group of data or control information. It is a logical and user identifiable set of information fulfilling special requirements. It is not a part of application and it is external to it. Definitely it should be external to the application program. It is referenced by the application as an external resource of information. It is counted as an internal data file for at least one application other than the currently concerned application. Now, user inquiries, the transaction should be an elementary process. An input request should enter the application boundary but without updating an ILF, that is internal logical file. The data should be retrieved without additional processing and without producing any derived data. Right? So with these 5 information domain, the first 3, 1, 2 and 3, that is the number of user inputs, number of user outputs and number of inquiries. These are data function types, whereas internal files and external files are called control files, control types, control function types. So once data for 5 information domain are collected, complexity values associated with each count. So the table is drawn in this manner. These are measurement parameters, 5 information domain, number of inputs, number of outputs, number of inquiries, number of internal files and number of external files. Now here counts are written and then some weights are assigned to each parameters. In the weights are given in simple, average or complex, like this. Say for random sample software, number of inputs has been taken as 5, outputs as 4, inquiries as 6, internal files as 3 and external files as 4. Now weights have been assigned. For input simple it is 3, average 4, complex 6. Similarly for outputs, number of inquiries, and for internal files and external files. Now with this count, each weight is multiplied. Say 5 into 3 equal to 15, 5 into 4 equal to 20 and 5 into 6 equal to 30, and these 3 are added. 30 plus 20 plus 15 gives 65, so 65 is written here. Similarly 4 multiplies all these 3 weights, 6 multiplies all these 3 weights. So in this way we get the total count of each parameters, and finally when we sum it up we get unadjusted function point count. So with the help of this UFPC we keep it aside and now we compute TCF, total complexity factor. For this total complexity factor there is a GAC list, general application characteristics, and these are 14. Albrecht suggested 14 characteristics for estimation of every software. So this is number of characteristics, these are application characteristics, and it is degree of influence. Degree of influence is given on this scale: 0 no influence, 1 incidental, 2 moderate, 3 average, 4 significant and 5 essential. So for a particular software we assess reliable backup and recovery. Say for example in case of banking software or railway reservation software, we take it as 5. It should be essential. Data communication required for banking or railway reservation, we take it as 5. Distributed processing functions, we again take it as 5. So depending upon the nature of software, we provide degree of influence value, DI value, and then summing these DIs, we get the total degree of influence. So here it is 46. Then we compute TCF, total complexity factor. TDI is equal to summation of DI from 1 to 14, and TCF is equal to 0.65 plus 0.01 into TDI. And our TDI is 46. So multiplying 46 with 0.01 and then adding to 0.65, we get 1.11. So TCF is here 1.11. This is the formula for FPC, UFPC into TCF, or this is another, the same is written as such, UFPC into 0.65 plus 0.01 into TDI. So our UFPC is 457, that has been calculated, and now TCF is 1.11. So here we get function point count as 507.27. So this gives the size of the software in terms of function point count, 507.27. So with this, we can estimate the productivity as size by effort. We can estimate function point per person month, quality, errors per function point or defects per function point. Similarly, we can estimate the cost, rupees per function point, and documentation, pages per function point. So this is all about function point metric. So in this metric, I'm just revising. We compute two things. One is UFPC, computation of UFPC, unadjusted function point count. Here we have taken 5 information domain characteristics: number of user inputs, number of user outputs, number of user inquiries, number of internal logical files, ILF, number of external files, and the counts are written here. Then we provide weight as simple, average, and complex. Multiplying each weight, simple, average, and complex, with count, we get total count. And vertically, when we sum these total counts, we get unadjusted function point count. Now, after this, we compute TCF, total complexity factor, on this 14 GSE, that is general application characteristics, giving DI value to each characteristic. Summing all these values, we get TDI, and on the basis of TDI, we compute TCF. Finally, we compute FPC as UFPC into 0.65 plus 0.01 into TDI. And in this way, total function point count is calculated. That's all for the day. Thank you.